So, around the year 1600, William Shakespeare wrote Hamlet's to be or not to be soliloquy, which would go on to become one of the most widely recognized texts in the English language. Now, while Shakespeare was contemplating questions of life or death, I've been thinking about a different question, which is to mock or not to mock. And more specifically, when we're writing tests for our code, how do we decide when to use a mock? My name is Emily Giurleo, and I'm a software engineer at Numero, where we make financial software for political campaigns. I'm also the co-founder of WNB.RB, which is a virtual community for women and non-binary Rubyists. Going back to the question I just posed, how do we know when to use a mock in our tests? This is the question I plan to answer over the course of this talk. And in doing so, I want to achieve the following goals. First, I want us to understand what mocks are and why it's so difficult to figure out when to use them. I also want to identify 3 scenarios where mocks can be the most helpful and valuable in our tests. And in doing so, I want to articulate a framework that we can use going forward to help us decide when to use mocks. So, when I say the word mock, what do I mean? Well, when we're writing tests, there are kind of 2 high-level approaches that we can use to decide to create the objects that we're going to use in our tests. The first is called the classical approach, and this is when we create real objects and then verify their internal state. The second is called the mockist approach, and this is when we actually create fake objects, and instead of verifying their state, we verify their behavior. And I'm going to show you some examples of the differences between these 2 approaches. Let's imagine that we ran a store in the 16th century, and like any good 16th century store owner, we want to create an application to manage our inventory. Our application might have 2 main objects. The first is a warehouse that keeps track of how much inventory we have in each of our warehouses. And the second is an order, which represents an order from a customer. Now, the order object might have an instance method called fill, which takes a warehouse and then removes any inventory from that warehouse, depending on what items are in the order. I'm going to show you how I might test these objects, but before I do that, I just wanted to say, I use RSpec and RSpec mocks in my day-to-day life as a software engineer, and all of the examples in this talk will use those gems as well. But please don't get up and leave if you're a mini test user. I think that the concepts I discuss should be relevant to any testing framework or even like other coding languages. So please stick around. So back to our inventory manager. If we were going to test the fill method using a classical approach, we might do something like this. So we could create a real warehouse object, and we could add some inventory to it, say ruffle collars and quills and ink, which are, of course, 16th century staples. Then we can pass that warehouse object to the order fill method. And finally, we can verify the internal state of the warehouse at the end of the test. We can check that it has 10 fewer ruffle collars at the end than it did at the beginning. Now, what if we tested it using a mockist approach? Instead of creating a real warehouse object, we can create a fake object using the instance double method. And then we can define the expected behavior of our fake object. We can say which methods we expect to be called on it, even with which arguments, and we can define what we want those methods to return when they're called. Finally, after we pass that fake warehouse to the fill method, we can verify that the fake object had the right methods called on it, that our fill method behaved as we intended. Now, looking at these 2 approaches, we might ask ourselves, which is better? And I'm just going to tell you that this is a trick question. I think there are benefits and drawbacks to both approaches. The classical approach was arguably simpler. It had fewer lines of code. I think it was easier to reason about. But a cool thing about the mockist approach is that not only did we verify the result of our method, but we verified that our code achieved that result in the way we expected, which seems really powerful. However, I think that verification comes at a price, and I'll show you what I mean. So let's go back to our mockist tests. Imagine we wrote these tests, and then 6 months later, we decide to go and refactor our application, our fill method. An interesting thing is going to happen, and that this test is probably going to break the moment we try to refactor the method. That's because our test is deeply coupled to the exact implementation of our method. And so this is a huge downside of mocking. We couple our tests to our method, which will break the tests the moment we try to refactor. Another huge potential downside to mocking is that, and this happens to even the most experienced developers, is that we can get into this hole where we mock so much that we remove all meaning from our tests. So let's imagine that we create also a fake order object. And then we mock the fill method, the method we're trying to test. Then in our test, we call the fake method on the fake object. And then we have the test verify that we called that fake method on the fake object. We've essentially just written a test that tests itself. It has no meaning, and it's entirely self-referential. And mocking can potentially get us into a situation like this. So to summarize, at its very worst, mocking can help us write tests where our tests are coupled to the exact implementation of our code. And it can cause us to write tests that are entirely self-referential. That's right, Shakespeare. Mocking is risky business, and that's why it's often so hard for us to figure out whether we should be using mocks in our tests. However, not all hope is lost. I think mocking does actually come with a few benefits, a few scenarios where it can add real value to our tests. And I've identified 3 of those scenarios that I want to talk to you about today. The first is that mocking can help us prevent the use of expensive resources in our tests. It can also create deterministic tests for non-deterministic code. And finally, it can help us test objects whose state can't or shouldn't be exposed. In going through these 3 scenarios, we're going to work together to identify a framework that we can use going forward to answer the question for ourselves, to mock or not to mock. To illustrate these concepts, I'm going to be talking to you about a gem that I wrote for this talk called Fakespeare. The Fakespeare gem generates silly Shakespeare quotes with random Ruby words interspersed if you call the method generateQuote. The generateQuote method works as follows. First, it makes a network call to a Shakespearean quote generator API and gets back a Shakespearean quote. Then, it identifies the nouns in that quote, and I'll admit it does this to varying degrees of success. And then it replaces those nouns with randomly generated Ruby words. This method is extremely silly and has no practical use case. But it does demonstrate all 3 of the concepts I want to discuss in this talk, which makes it the perfect way to show you what I mean when I say to mock or not to mock. So let's get started. The first scenario that I wanted to share with you was, I think, one that we encounter in our day-to-day lives as software developers, the case where mocking can help us prevent the use of expensive resources in our tests. Now, what do I mean by expensive? I think expense can be determined in any number of ways, but some popular ones are time, like we want our tests to run quickly, computer memory, we don't want our tests to become bulky and crash our computers, and even money, we don't want our tests to be expensive, monetarily expensive to run. One example of something that could be expensive is a network call, and we just saw that I use one of these in the generateQuote method. The first thing it does is it makes a network call to a Shakespearean API to get back a quote. What I mean by a network call is that it uses the internet to perform a query against an API that lives on a different server, not on the same server as the gem is running. So I don't want to run this network call during my tests, and that's for a few reasons. First, network calls are slow, and we want our tests to be fast. And secondly, depending on what API provider we use, I actually wrote the Shakespearean API, but let's pretend that I didn't. Our API provider might charge us money for every request, or if we make too many requests, they might rate limit us and then charge us to allow us to continue using the API. Shakespeare doesn't have time for this, and neither do I, so I think this is a great scenario where we can use a mock. Before we talk about how we might mock this, let's take a look at the code that I wrote to actually perform the network request. So first, I create a URI object, and this is just an object that specifies the address of the server that the API lives on. Then I use the net HTTP library, specifically the getResponse method, to perform the network request. Now, when I was going to mock this code, I was thinking to myself, how should I mock it? How should I approach this? And I thought, maybe I should mock this method, the method that's actually making the network request. Does that seem like a good idea? I'm going to say no. I got some, I don't know, from the crowd. And I'll tell you why I don't think that's a good idea. First, if we mock the net HTTP library, our test has to know the exact implementation of this third-party method. It has to know what arguments it takes and what kind of objects it returns, which seems like a lot of work for us in just like setting up our tests. Also, doing this would couple the test to the exact response shape that we get back from the API. If the API provider, aka me, ever wants to change that response shape, then we have to change all of our tests as well. So in order to avoid these problems, I think we can do something kind of clever, which is extract this external dependency, this network request, from the code of the rest of our gem. And we can do this using something called the client pattern. The client pattern just means that we create a custom class around this external dependency, this network request, called a client, that essentially shields that code from the rest of our gem. Now, instead of our gem, and by extrapolation, our tests having to know the exact implementation of our network request, all it needs to know is that there is a method on this class where it can say, hey, give me a quote, and the class will give it back a quote. This also makes it really easy to test, which I'll talk about in a second. First, I'm going to show you the Shakespeare client that I wrote to encapsulate this network request. So you'll notice that first, a lot of the code on this slide is the same as the previous slide. The only difference is that it's in its own class, which has some awesome benefits. The first is that the gem no longer has to interact with net HTTP. It no longer needs to know exactly how this network request is implemented. It also no longer needs to know the exact response shape from the API. So if I ever go and change that response shape, I can keep all that complication within this class and leave the rest of the gem the same. If we were going to mock this, it's actually quite straightforward now. We can create a mocked instance of the Shakespeare client. Then we can even force the Shakespeare client class to return that mocked instance when we call the new method. And finally, we can define the behavior we expect on the Shakespeare client that we've mocked. We can say we expect it to have a certain method called on it, and when that method is called, we can say exactly what quote we want it to return. In this section, we talked about how mocking can help us prevent the use of expensive resources in our tests. And we can use patterns, such as the client pattern, in order to help us mock in the most effective way possible. I think this leads us to add the first question to our to mock or not to mock framework, which is, does our test use expensive resources? If so, that's a good indication to us that we might want to use a mock in our tests. The second scenario I wanted to talk about is when mocking can create deterministic tests for non-deterministic code. An example of what I mean when I say non-deterministic is like an error case that happens when you least expect it. So remember we said that the first thing the generate quote method does is perform an API request. But what if that API request fails? What if instead of a quote, we get back a network error? This is an error case that is hard to anticipate. We don't know when the internet might go down or when the Shakespeare API might be experiencing a problem. That being said, we still want our gem to handle it well, which means we still want to test it. The other interesting thing is that this case then becomes hard to test because we can't just tell our test, hey, shut off the internet for a second. Like, that's pretty hard to do. So we can lean again on our client pattern. In this case, I have the client, whenever there is a problem performing the network request, raise an exception, a custom exception class that I wrote called Shakespeare error. And that way, the rest of the gem can rescue that error and perform some exception handling whenever there is an issue with the API request. So if we were going to mock this scenario, it's actually really similar to the scenario we discussed before. And the only difference is we can force the mocked client whenever it receives the generate quote method to raise an exception with whatever error class that we want and whatever error message that we want. So in this way, we've taken a non-deterministic error case and we've made it deterministic for the purposes of our test. Another example of non-deterministic code is side effects. And when I say side effects, I mean inputs that aren't explicitly passed as arguments to a method. And that can be like a call to time.now within the method, or like some random generation that happens within the method. And we talked about this earlier. We have an example of this in the Shakespeare gem. The last step of the generate quote method is that it takes those nouns that may or may not be nouns, sometimes they're verbs, in the Shakespeare quote, and it replaces them with randomly generated Ruby words. And so this case is really hard to test without mocking because the words are randomly generated. The outcome is not going to be the same every time. So by mocking that random generation, we can take this non-deterministic part of our test and make it deterministic. And I even took my own advice here. I extracted those randomly generated Ruby words into their own module, which I called Ruby words, and that made it really easy to mock. So in this section, we talked about how mocking can take a non-deterministic case and create deterministic tests for it. And I think that leads us to the second question we can ask ourselves when we're deciding to mock or not to mock. And that is, are we testing a non-deterministic case for our code? The final scenario I wanted to talk about where mocks can really benefit us is using mocks to test objects whose state can't or shouldn't be exposed. The best example that I've come across for this is a cache. Now, there are many different types of caches, but for the purpose of this talk, I'm going to say that a cache is a software layer that temporarily stores data for the purpose of returning it more quickly in the future. Now, the cache that we interact with most is probably our browser cache. So we go back to our friend, Willie Shakes. He loves to visit his favorite website, which is rufflecollarsrus.com. I mean, who doesn't love to visit that website? And when he visits the website, his browser essentially, this is a gross oversimplification, but for the purpose of this talk, I think it'll suit us. His browser makes a request to the site's server and gets back some assets that it can use to display the site. Then what it does is it stores those assets in its local browser cache so that the next time Shakespeare visits this website, which he does very frequently, the browser is actually going to make a request to the cache, and it's going to load those same assets from the cache instead of making another network request to the server. Remember, we said network requests are slow. Shakespeare wants his site to load quickly, and so this is like an optimization that the browser can use in order to provide the best experience possible. Now, browsers aren't the only place where we can use a cache. In fact, I think there is a great use case for caching in the Shakespeare gem. So remember, we talked about how the gem makes a network request to the Shakespeare API. But sometimes that network request doesn't work, and instead of a quote, we get back an error. What happens to the rest of the method in that case? Do we just raise that exception and then call it a day? I don't think that's a great use case for the myriad users of this gem. I assure you there are many. What if we could use caching to improve the experience there? So actually what I've done is that whenever the Shakespeare gem gets a quote back from the Shakespeare API, I have it store that quote in a cache. Then in the future, if there's ever an issue getting a quote back from the API, the gem can just make a call to the cache and get back a quote it's already saved, which provides a better user experience in the case that the internet goes down or the Shakespeare API goes down. This cache is incredibly hard to test, and that's for a few interesting reasons that I'll share with you. So going back to the case where the Shakespeare gem makes a call to the Shakespeare API, gets back a quote, and stores it in the cache. We want to make sure that it does this reliably. And so I think our first instinct, would be to check the cache at the end of the test and to say, is the quote that we expect to be in there actually in there? However, I don't think this is the best approach that we can take. And the reason is that I don't think the state of the cache is meant to be examined. Here's what I mean by that. So I've been talking about the cache, but at its very fundamental level, the cache is just an array of strings, right? All of the quotes that the gem has put in there over the course of its usage. When I say the state of the cache, what I mean is this underlying data layer, this array of strings that provides the information that's going to be used by the cache. I don't think that the rest of the gem should be able to see this implementation of the cache. Instead, I've only provided two methods that the gem can use to interact with the cache. The set method, which will add a new quote to the cache, and the get method, which will get back a single quote. There is no method that's just like, hey, give me all the quotes you got in there, because that couples the rest of the gem to the exact implementation of the cache. If I ever want to go back and rewrite that implementation of the cache, then I'm going to have to also rewrite a huge part of the gem, which sounds like a lot of work for future me. So while it might be tempting to peek into the cache during our test and say, hey, is our quote in there? I don't think that's the best idea. And I think mocking actually saves us from coupling our gem to the exact implementation of this component. So in order to mock this case, it's very similar to the previous examples we've seen. We can actually define the method that we expect to be called on the cache, the set method. And in this case, we don't even need to mock the behavior of it. It's totally okay if the cache just does what it would normally do. And we can use the rspecs and call original method in order to just have it do that. All we want to do is see that the correct method is called, and then we can do that at the end of the test. The other scenario that we might want to test with the cache is that when the Shakespeare API fails, the gem properly gets a quote from the cache and then completes the rest of the method. Now, this scenario is also really hard to test for an entirely different reason, which is that the outcome of using the cache looks exactly the same as the outcome of not using the cache. From the experience of the user of the gem, if the Shakespeare API fails and the gem gets a quote from the cache, or if the Shakespeare API succeeds and the gem gets the quote from there, my experience is exactly the same. So it's really hard to use the classical method of testing because it's verifying the state in this case is going to result in the exact same result. That was a good sentence. So what we can do here is use a mock to help us verify the behavior of the gem to make sure it's properly using the cache when we expect it to. So in the case where the Shakespeare API fails, we can define the expected behavior of the cache. We expect it to have the get method called on it. Then, in our test, we can make sure that that method actually got called. On the flip side, we might also want to test that the gem doesn't use the cache in the case where we don't expect it to. And so we can use rspecs not to method, as in when the Shakespeare API succeeds, we expect the cache not to have received a certain method because there's no reason for the gem to have used the cache in that case. So in this section, we talked about how mocks can help us test objects whose state can't or shouldn't be exposed, like a cache. And in doing so, I believe that we've completed our framework for deciding whether or not to mock with the question, are we testing an object whose state can't or shouldn't be exposed? So now our framework is complete. When we're deciding whether or not to mock, we can ask ourselves 3 questions. The first is, does our test use expensive resources, such as time, memory, or money? Are we testing code that's non-deterministic? And finally, are we testing an object whose state can't or shouldn't be exposed? If the answer to any of these questions is yes, I think that we are using mocks in a way that's most effective and that adds value to our tests, and that in this case, we should mock away. However, if we answer no to all of these questions, then mocking might not be such a good idea. However, I don't think that we should despair in this case. If we answer no to these questions and we still have this temptation to use a mock, it actually tells us something really interesting, which is probably that the code we're testing is hard to test for some reason. That might be that we haven't properly extracted side effects, or maybe we've written a class that's just doing too much. Whatever the case may be, the temptation to use a mock should give us a signal that maybe there's something in our code that can be changed to make it easier to test. To quote the Bard, the fault might not be in our code, but in fact, in our tests. Once again, my name is Emily Giurleo. If you would like to talk to me about this, I don't think we'll have time for Q&A right now, but you can follow me on Twitter. And you can also visit my website, emilygiurleo.dev. If you'd like to check out the Fakespeare gem, it's real. It's not very usable, and I don't really know what you'd use it for, but it was really fun to write, so feel free to look at it on my GitHub. And I also read some awesome articles when putting together this talk, so I'll put these slides up on my website, and you could check those articles out. Lastly, I just want to mention something that's been really near and dear to my heart over the past few months, WNB.RB. It is a community. It is a community for women and non-binary Rubyists. We have a monthly meetup and a Slack workspace of now over like 250 people, which is so awesome. So here are some links where you could check us out. Thank you so much for coming to see my talk. Please mock responsibly and enjoy the rest of your RubyConf.